Lastly, in this section, we want to be able to verify the solution. Verify the solution. If they give you a solution, then can we take that solution, basically plug it back into the problem to show that indeed this is the solution. Later on, we will talk about how to actually produce those solutions on our own. So the way I do this is what I expect for you to do even on the test. Verify that the given functions form a fundamental set. Fundamental set means, anybody? If a set of functions are fundamental, if they form a fundamental set, what does that mean? That they are what? That these functions are yes, sir, linearly independent. So that's all they're saying, that these functions are linearly independent. On the here, the indicated interval, this would be all real numbers. Uh, and so then it says form the general solution. Let me ask this to see if I can pick your brain. How will we be able to form the general solution? What concept would we use? What's the principle? I've given half of it away already. There's a principle that says this is how the general solutions look, whether it's a homogeneous differential equation or a non-homogeneous differential equation. Let me ask you, for this problem here, is it homogeneous or is it non-homogeneous? It's homogeneous. Now, why is it homogeneous? Because of that zero sitting over on the right side. Okay, so it's homogeneous. If it's homogeneous, then we call its solution the complementary solution, and we say that the complementary solution looks like some kind of format, and that format is based on what principle? So I reckon the last class I was just talking to myself, which I'm getting used to that, by the way. What's the principle called? No? Superposition principle. That's how we form the general solution. So here we say let y equal to e to the negative 3x be a solution to the given differential equation. Now in the differential equation, there's a y, which this is what this y is supposed to be. There's a y prime and there's a y double prime. So y prime is negative 3 times e to the negative 3x. And y double prime is 9 times e to the negative 3x. So we just substitute now. Y double prime, here we have y double prime minus y prime minus 12y. So that's equal to y double prime, 9 times e to the negative 3x. Then it's minus y prime, this is parentheses, negative 3 times e to the negative 3x. Minus 12 times y is e to the negative 3x. Now we simplify this. This is 9 times e to the negative 3x plus 3 times e to the negative 3x. minus 12 times e to the negative 3x. That gives us 0. Right? So we've just verified one solution. So now we do the same thing for the second solution. Let y, and typically we'll say y sub 1 and y sub 2, so to show that there are two solutions. Let y sub 2 equal to e to the 4x. Well, this implies, well, I need to say, let this be a solution. So now we say this implies that y prime is equal to 4 times e to the 4x, and y double prime is 16 times e to the 4x. So we have y double prime minus y prime minus 12y. This is equal to y double prime is 16 times e to the 4x minus y prime, that's 4 times e to the 4x, minus 12 times y, that's e to the 4x. Well, 16 minus 4 is 12. Minus 12, we get 0. So then we conclude, according to the superposition principle, y sub c, the c represents the complementary solution, because the complementary solution is said to be the solution to the homogeneous linear differential equation. So we say by the superposition principle, we state the claim by which we are using to say whatever we're going to say. So I'm not saying, this is what Pookie told me, this ain't what Ray said. You can't go on what Pookie and Ray said. They're just talking. I need to have some stronger evidence than Pookie and Ray. So, and the stronger evidence is the superposition principle. You see what I'm saying? A lot of times, we do things, whether it's mathematically or things in life, and we have no reason why we're doing it. That's not good. But it's the fallacy of man. It's the fallacy of man. So thank God for grace. So we conclude, therefore, by the superposition principle, we can write the solution to the homogeneous differential equation as y sub c is equal to c sub 1 times e to the negative 3x plus c sub 2 times e to the 4x. And the c stands for what again? This c here, y sub c, stands for what? Complementary. Thank you, my friend. Is that John? Is that John Isbell? Thank you, ma'am. I think you have a trip. Is it with the fishing group? It's not you? That's you. Okay. Baseball. Okay. Good. You keep talking like that, John. I don't mind you going off. Going somewhere. You talking good. I like that, man. You go and do what you got to do and come on back. Yes. So this y sub c is said to be the complementary solution. The complementary solution matches the solution for the homogeneous differential equation. y sub c is, this is called the complementary solution. Okay, let's look at another one. Let me move on to this problem here. Verify that the given two parameter family of solutions, of functions, is the general solution. Here, this is for the non-homogeneous differential equation on the indicated interval. So here's what we have. We have here y sub 1 is equal to e to the 2x, and y sub 2 is equal to e to the 5x, are said to be the solutions to, are said to be the solutions to the homogeneous differential equation. To the homogeneous. Which is y double prime minus 7 y prime plus 10y equal to 0. Should be an and yes, and y sub p equal to 6 times e to the x. I'm getting it from here. Y is said to be the solution. This is said to be the general solution. This is written in terms of the superposition principle, that the c sub 1 times e to the 2x plus c sub 2 times e to the 5x, the e to the 2x, e to the 5x, is said to be the complementary solutions. Plus, this is a particular solution based on this g of x, and g of x is 24 e to the x. It's not a homogeneous differential equation anymore. It's a non-homogeneous differential equation. You change up this value here, put something else here, then this number, this value changes, right? Obviously. Right? You take an algebraic problem, you change a number in the algebraic problem, the solution changes, right? So, and y sub p is said to be the particular, that's what that sub p stands for, particular solution to the non-homogeneous differential equation. So one, we verify that y sub 1 is equal to e to the 2x. So this here implies that y prime is 2 times e to the 2x, and y double prime is 4 times e to the 2x. So what we have is y double prime, look at the problem, y double prime minus 7y prime plus 10y, that has to equal to 0. So here I get y double prime, that's 4 times e to the 2x minus 7 times y prime, that's 2 times e to the 2x minus 10 times y. Y is e to the 2x. So we get 4 minus 14. Missing, my sign is messed up. That's a plus sign there. Plus 10. Right. So that's minus 14 plus 4 is minus 10 plus 10, 0. That's better. And then, secondly, we verify y sub 2 equal to e to the 5x. Well, this implies that y prime is 5 times e to the 5x, and y double prime is 25 times e to the 5x. So we have y double prime minus 7 y prime plus 10y is equal to y double prime is 25e to the 5x minus 7 times y prime. That's 5 times e to the 5x, and then plus 10 times y, but y is e to the 5x. So let's see what we get. We get 25 plus 10 is 35, minus 35, we get 0. That's good. Now, thirdly, we must verify that y sub p equals to 6 times e to the x. We're getting that from here, right? So verify that y sub p equal to 6 times e to the x is a solution to y double prime minus 7y prime plus 10y equal to what? We're verifying that 6 times e to the x is a solution to the homogeneous or the non-homogeneous? The non-homogeneous, right? So we have to say this is equal to that 24. I need to erase that. I can't see. This is equal to 24 times e to the 2x. 24 times e to the x, excuse me. So what we do here is we say y, okay, it's a broke down looking y. Okay, y, let y. In my Three Stooges voice, okay, let, okay, it's the wrong crowd. So. You can't beat the old shows, man. You know, that's where life was, you know. Three Stooges. Abbott and Costello. Anybody know about Abbott and Costello? Okay. 2. Boy, I tell you. That's the best stuff. Huh? That's right. What's on second? Bravo, bravo. For he's a jolly good fella. No one can deny. So, so let y equal to this 6 times e to the x. This implies that y prime is, take the derivative, you still get the same 6 times e to the x. And y double prime still 6 times e to the x. So here we have y double prime minus 7 y prime plus 10y. That's equal to 6 times e to the x minus 7 times parentheses 6 times e to the x plus 10 times 6 times e to the x. Well, here we don't want our answer to be 0 because we're dealing with the non-homogeneous differential equation. So we break that down. So here we get 6 times e to the x minus 42 times e to the x plus 60 times e to the x. And so we get 66 minus 42. That gives us 24 times e to the x. Okay? So on the test, I'll give you a problem just like this problem right here. And I ask the same thing. I need you to show me, 1, show that y sub 1 is a solution. Secondly, show that y sub 2 is a solution. And then thirdly, show that y sub p is a solution. All you're doing is just verifying. So you just plug in the information back in, verifying the left side equal to the right side, whether it's 0 for the homogeneous part or that is whatever that term is for the non-homogeneous part. That's all you have to do. Now it seems obvious, of which it is. It seems redundant, of which it is. But there's a learning process going on. There's some concepts in there that's important to know. One, you understand when you write that out, you understand the superposition principle. You understand it, why the superposition principle is applied to how I write out the solution. That's important. That's important. Why is it important? It becomes important because from hereafter, you start dealing with higher order differential equations, higher than 1, then all your solutions, if it's a second order differential equation, your solution is at most 2 solutions. And you write those 2 solutions out based on the superposition principle. If it's a third order differential equation, y triple prime, then your solution is at most 3. That means that you may have no solution, you could have 1 solution, you could have 2 solutions, you could have 3, but at most 3 solutions. How are those solutions written out? Based on the superposition principle. Doesn't matter. If you have a fourth order, it's possible to have 4 solutions. How are they written? Like this. If it's in linear algebra, the same way you write your solutions over there as well. Okay? So, I'm finished with this section. Let's cover 4.2. Give me 15 minutes there for 4.2, and then the rest of the time I give the first of 3 parts to 4.3. Any questions here before I close out? Any questions?